Hi everyone, here we are, another day, another special function. We are looking at step functions today. You might have never heard of these before, so stay tuned. Exercise 1. An electrician works at a job site at a rate of $40 per hour. If you stopped there, you would be thinking $40 every hour. So you would be thinking another hour, another $40. So at 1.5 hours, you might think you'd be at $60. Well, that's not how this works. He's going to charge you $40 as soon as he comes, up to the first hour, and then $40 for the second hour, another $40. So if we look at a graph, this is what this means. As soon as he gets there, 20, 40, you're on the clock, $40, up to the first hour. If he stays for 1 hour, you will have paid $40. If he stays longer than an hour, he's going to jump up to another $40 and start charging you $80. So after 1 hour, you're up here. If he stays for that long, you'll be paying $80. If he goes over 2 hours into the third hour, you'll jump up to 120. You'll pay 120 for that next hour. If you notice, I'm struggling with these endpoints, and we'll talk about this in just a minute. After that, another hour. So if you go over 3 hours, you will be paying $160 into this hour. And if you go over 4 hours, you're going to have to pay $200 for into the fifth hour. Okay, so that's the cost as he works different hours. It's called a step function. I bet you can't guess why. Looks kind of like steps, right? Part B, how much does he charge for working 3.5 hours? We want you to circle the point on the graph that shows this answer. So I'm going to go to my graph. Remember, hours is on the x-axis. 3.5 would be right here. And if you go up to the function, it looks like for 3.5 hours, you would be paying $160. So that's the point 3.5, 160. Step functions are rather simple because they consist of a series of multiple horizontal lines. Horizontal, this direction. When reading their formula definitions, it's important to pay attention to the domain intervals. So I mentioned a few minutes ago about this open circle versus closed circle thing. That's because the domain breaks at these different points, the x values. So a step function is defined in exercise 2 with this piecewise formula because it's got pieces of graphs. We're going to graph it on the grid at the right. I want you to notice that there's 3 pieces. F of x is 2, or y equals 2. F of x is 5, or y equals 5. F of x is negative 4, y equals negative 4. And we're breaking from 0 to 3, 3 to 5, and 5 to 10 on the x-axis. So I'm going to start with my first piece, a horizontal line from 0 to 3. So here's 0, here's 3, 4, 5 is right here, 6, 7, 8, 9, 10 is right here. Those are the domain values, the x values. Look at the first piece, f of x equals 2. So y equals 2, 1, 2. While I'm between 0 and 3, I'm on this horizontal line. Go back to your function, look for the closed circle, open circle. Remember, closed circle, open circle. This is included, this is not included. So, closed circle, open circle. Now I'm looking at the next piece right here, f of x equals 5. I'm going to do this in green. 3, 4, 5. And I'm going to start from 3 with a closed circle and go to 5 with an open circle. Now I'm looking at the next piece. I'll do this in blue. F of x equals -4. So starting at 5 with a closed circle, I'm going to be down at 1, 2, 3, -5. I'm sorry, -4. At 5, I'm down at -4. From 5 all the way to 10, look at the function and tell me if I should have an open or closed circle. And if you said closed, you are right. So I have these 3 horizontal pieces. I'm going to evaluate the function. F of 5. When x is 5, what is y? 5 is right here. That's not included, but this point is. It's -4. If you look at the function at 5, you would be looking for the closed symbol, and you'd follow this piece, -4. So we're right. Let's look at this one, 3.5. 3.5 would be right here between 3 and 4, and that hits the green piece, so we're up at 5. That's just the point, 3.5, comma 5. Let's look at 2.7. When x is 2.7, 1, 2, 2.7, you'd be right here on this red piece, and your y value would be 2. That's just the point, 2.7, 2. And if x was 0, so 0, comma, where are we? Let's look at the graph. At 0, we are at 2. 0, 2. Let's look at the function. When 0 is included, we're on this piece, the 2. It's all about choosing which piece of graph you should be on. State the domain, state the range. The domain, if you look at the function, starts, oops, I don't know what that was. The domain starts and includes 0. It breaks at 3, but 3 is included, not here, but, oops, not here, but here. Keeps going, stops, breaks, picks up again at 5. So there's no break, really. 5 is not included. Oops, 5 is included. 10 is included also. So we are including everything, even though we're jumping from 0 to 10. The range jumps. The lowest value is -4, jumps up to 2, jumps up to 5. So the range is like a set of values. It jumps from y equals -4 to y equals 2 to y equals 5. And always list your values from low to high. All right. Explain why this is a function. If you remember what a function means, each x has only one y value. So I'm looking at this function and I'm thinking, as I move along the graph, each of these different x values only hits the graph once. Here it doesn't hit, but here it does. Hit, 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 doesn't hit, hits. So at the weird points, where these points align, it's only hitting one spot. Where these points align, it's only hitting one spot. There's no overlap. We could say it passes the vertical line test. And we could say each x has only one y. Okay, turn the page. And this next question is a word problem about engineering. So it says, in step functions are used in engineering. It's about a pumping station, actually. Pumping station. Step functions are used to signify when they have changes in constant rates. These functions can give rise to then to piecewise linear functions, so pieces of graphs. Pumping station is draining a reservoir with a set of pumps. I can't talk tonight. With a set of pumps that drains the water, or that drain the water at a rate of 250 gallons per hour. Oh my gosh, now I can't stop laughing. After 5 hours, additional pumps are turning on such that they pump at an overall rate of 600 gallons per hour for the next 7 hours. So we're going to draw this graph, and if you notice, we already have these labels. These are the gallons per hour, So 100 gallons per hour, 200 gallons per hour, 300, 400, 500, 600 gallons per hour. And down on the bottom is our hours. Always pay attention to the units on the graph. All right, so let's read it again more carefully here. We're starting at 250 gallons per hour, and then it changes after 5 hours. So we're starting at 250 gallons per hour, 4 hours, 5 hours. We got to decide, should that be opened or closed? It says after 5 hours, so I'm going to say we're going to close that. As soon as we step away from 5 hours, so even the slightest bit of a step away from 5, we're going to jump up to 600. So we're going to go all the way to 600 for the next 7 hours. That would take us to 12 hours. So now we're up here at 600 gallons per hour as soon as we go over 5. So even at 5.0001 seconds. There's our graph. Okay, so how many gallons of water are pumped out of the reservoir over the 12-hour period? Well, let's take a look at that. For 5 hours, we were pumping at a rate of 250 gallons every hour. So if you remember dimensional analysis, we can kind of cancel off these hours and multiply 5 times 250. So that would be, let's see, 1,250 gallons. And then we got 7 hours at 600 gallons every hour. That's another 4,200 gallons for a total of 5,450 gallons for the 12-hour period. The reservoir originally contained 8,250 gallons of water. So how much does it contain after 5 hours if water is only pumped out? So we're going to take our 8,250, sounds like a subtraction problem, and we already figured out our 5-hour amount of water, which was 1,250 gallons. And if we subtract that off, we get 7,000 gallons. Engineers want to turn off pumps when the reservoir reaches a level of 2,000 gallons. Will they need to turn off the pumps during the 12-hour time period? Well, if we have 8,250 gallons, and we subtract what we can do in 12 hours, which was part B. So from part B, 5,450 gallons, we're going to be left with 2,800 gallons. So we got to answer the question. Will they need to turn the pumps off? Show evidence to support your yes or no answer. So make sure you say yes or no. I'm going to say no, they won't need to turn the pumps off because 2,800 gallons is greater than 2,000 gallons. They'll still have enough water and they won't need to turn the pumps off. And I showed some evidence. I showed my subtraction. Assuming engineers do not turn off any pumps, how many total hours will it take to the nearest tenth of an hour, this is not going to be a nice answer, to drain the reservoir of all of its water? Well, we know it took 12 hours so far to get us down to 2,800 gallons. So really we just need to drain the rest of that. And according to our graph, we're at 600 gallons every hour. So we got to take our 2,800 gallons and we got to subtract off for how, I don't know how many hours, 600 gallons every hour. Let's say X equals the number of hours. So let's say I want to do 2,800 minus 600 gallons every hour. And I want that to go down, oops, I want that to go down to 0. So I'm doing a little algebra here because we can. Subtract 2,800, try to get X alone. 2800. Negative 600x equals negative 2800. Divide by negative 600. Go to your calculator if you have to, but I know that it's 4.666 repeating. It said round to the nearest tenth of an hour, so I'm going to say that 6 makes that 6 go up. X is approximately 4.7 hours. I'm going to show you a quick proportion you could have done to do this also. So my proportion is, we're draining the water at 600 gallons every 1 hour. So I wrote 600 gallons to 1 hour is the same as trying to drain 2,800 gallons of water in X hours. So we got gallons to hours, gallons to hours. And I don't know if you guys learned about cross multiplication, but this cross product should be equal to this cross product if this is a true proportion. So you can cross multiply and say 600x, you kind of ignore the units once you get it set up. 600 times x would be equal to 2,800 times 1, which is just 2,800. Divide by 600, and x would be equal to 2,800 divided by 600. 4.6 repeating. 4.7 to the nearest tenth. And that was hours. Thanks. Enjoy the rest of your night.